Well, it looks like in these videos we're going to get a grand tour of my home. So this time we are out on the deck. The temperature has warmed up and winter hopefully is leaving us goodbye. Alright, so I've added a few files to our linked lists project. So this is the original linked list.py. That hasn't changed any. Well, I added the if name equals main so that I can include linked list.py into or import it into other files. I changed the name of linked list.py, as I mentioned in the bubble in the previous video, because I had named linked list.py the same thing as this class. And even though this is uppercase, it's not a good idea to have the same file name as you do a class name, because Python will treat this thing as a variable if you import it, and you don't want to have two variables with the same name. Then I imported linked list.py into Stack Overflow, and fairly soon we'll be explaining what Stack Overflow means, and created a stack from this linked list. I'm not going to show you that because that's one of your programming assignments, but I then created a stack example. Alright, so I'm importing Stack Overflow, which has my stack implementation in it, and I'm creating a variable, numbers, which is a stack, and then I'm pushing a bunch of numbers onto that stack, the numbers 0 through 9. Print off numbers, so I'm printing off the stack, and remember that the linked list method has a string method, and linked list is the parent of the stack class. So the stack class is going to make use of that print, or that string method. Now I am taking node to be the head of this stack, and then I'm just going to start popping things off from the stack. So I'm going to keep popping and until I'm done. So I'm going to be done when I've popped everything off. My stack returns none when there's nothing left on it. Alright, so let's take a peek at that. And I ran the wrong thing, so let's try this again on the stack example. And here is the stack after I have pushed all those numbers on, 0 through 9 right here. So I print those out, and then I start popping numbers off. So I pop off the last thing, then the last thing, until I get down to the 0, and finally the very last thing we print is none. Alright, so that is a very definition of a stack, right? Last in, first out. So the last thing on here was the 9. That's the first thing that comes out when you do a pop. Then the 8, and the 7, and so on. Alright, so the next thing I want to do is look at a way that you might use stacks. And stacks are used quite frequently in programming, as you might guess from the Stack Overflow website that's so popular in our class. So I'm going to give you a very standard example of using a stack. Okay, so suppose I want to evaluate an expression. So somebody types in this expression, parentheses 5 plus 2 times 3 plus 3 times 6. And that comes in as a string, and I want to evaluate that. Now, Python has built-in code to do this for you, but how does Python do it? There's a question. And the answer is it's kind of interesting the way this is handled. So we're gonna learn something new here, sort of related to stacks, something called postfix notation, or it's otherwise known as reverse Polish notation after the mathematicians that came up with it, which were of Polish origin. Okay, postfix notation means you write the operation after the numbers. So if I wanted to write 5 times 2, I would write 5, 2 times. And that means the same thing as 5 times 2. Fair so far? Alright, so 5, 2 times. Then 3 plus means multiply the 5 and the 2 using this operator. Then we come across this 3, And then the plus means, this plus means add the 3 to the previous computation of the 5 times 2. 5, 2, 3 plus times means we read through this thing, we read the 5, we read the 2, so we keep reading numbers until we get to an operation. When we get to an operation, we apply that to the previous 2 numbers. So this plus goes to the 2 plus 3, and then we multiply that by 5. Alright, 5, 2 divides 3 plus 4, 2, 3 plus times. You read the first 2 numbers, and then you get to an operation. You apply that operation to the previous 2 numbers, so 5 divided by 2. That results in a new number. So now there's a number here, right here, that's 5 divided by 2. So we have a number, and then 3, and then plus. This plus is applied to the previous 2 numbers, the 3 and the 5 divided by 2. So we're adding 3 to 5 divided by 2. Then we get a bunch more numbers, the 4, the 2, the 3, plus times divides. So the way this reads is we encounter this plus, that is applied to the previous 2, the 2 plus 3. Then we encounter a times, that's applied to the previous 2 numbers. So the previous 2 numbers are the 2 plus 3 and the 4. And then we encounter a divides, and that's applied to the previous 2 numbers, and the previous 2 numbers are the 5 divided by 2 plus 3 and the 2 plus 3 times 4. So when you write things in, this is called infix notation. Infix means the operator is in between the numbers. When you write things in infix notation, you have to use parentheses to specify the order of operations that you want. But it turns out that with postfix notation, you don't need parentheses ever. Kind of a handy thing. Okay, so remember this expression? That was the one we started with. How would that be written in postfix notation? So you might want to pause, take a minute to see if you can figure this out. But we want 5 and 2 added together. Then we're going to multiply that by 3. And then we're going to multiply 3 and 6. Whoops. Bad typing. And finally add those 2 quantities together. So this is the postfix notation for this infix expression. Alright, now what has this got to do with stacks? So suppose I wanted to evaluate this thing using a computer. So here's how the procedure works. I start pushing numbers onto a stack. So I push the 5 and the 2 onto the stack, and then I encounter a plus. When I encounter a plus takes 2 numbers. You pop off the previous 2 numbers, the 5 and the 2, and you add them. You take that result, 7, and now we've got this. So now we have a 7 on the stack. We read the 3, that is not an operator, so that pushes onto the stack. And then we find a times. That times is an operator, so we apply that times to the previous 2 things on the stack. So we pop the 7, we pop the 3 off the stack, and multiply them together. Then we have the 3, the 6, the times, and the plus. Wish this thing would get the hint where I want that equal sign. Now, we've got the 21. We read the 3, that's a number, it goes on the stack. Read the 6, that's a number, it goes on the stack. Read the times. The times means pop off the 2 previous numbers. So we pop the 3 and the 6 off, and we multiply those together, and now we have a 21 on the stack and an 18 on the stack. And once we've completed that, we read in a plus, and we pop off the 21 and the 18 from the stack, and we get an answer of 39. So I am going to now implement in Python a version of evaluating an expression, but the expression is going to have to be in postfix. Alright, so let's go look at my Python code, parser. Alright, so importing Stack Overflow. Remember, Stack Overflow is where I have the code for a stack. And I have a list of operations I'm going to deal with. I didn't put exponentiation in here. I could have easily, but I don't know. I just didn't. I create a stack. And then I create a thing that performs an operation. And there are other ways to do this in Python, or some built-in code to do this, but at this point I figured I'm rolling my own parser. Might as well do this too. So I pass in two variables, an x and a y, and an operation, and then I perform that operation on it. So if the operator is a plus, I add them together. If it's a minus, I subtract, times, multiply, and the only thing left that I have for operations is divides, and then I return that result. Now, I don't do any error checking in here, and if this program was something I was writing for real, then there would be some error checking, and I would need exponentiation and other things, but this is just keeping it simple. Okay. Now, I am going to get in an expression, and the expression is going to be a postfix expression, so something like 2, 3 plus, something like that. So I'm requiring... First of all, I'm requiring that the expression be a valid postfix expression. So for example, if I put another operation on here with a minus, that's not a valid expression. I've got too many operations for the amount of numbers I have there. This will add the 2 and a 3 with a 2, 3 plus, and that's going to try to subtract something, but there's nothing there. Not a valid postfix expression. So my assumption here is that this is valid. I could do some error checking inside of here to see if it's valid or not, but again, I didn't do that. I also require everything to be separated by spaces, a single space. And so I can split the string expression up by spaces, and that will give me then, for this example that I'm doing right here, that's going to give me an array that's split on spaces will be 2, 3, plus. So I get an array that looks like that, with that split. And those things are called tokens. So when you're evaluating an expression like this and using the parser, each one of these individual things is called a token. And what we need to know, are the tokens numbers or are they operators? And I'm not actually doing any error checking on that either. Should be, not. Again, keeping it simple. Okay. I'm going to do a for loop through, well, I should have maybe just left this here. I'm going to do a for loop through this array, and for each token in tokens I check to see if it's an operator or not. So remember, I had this list of operators up here. I check to see if token is one of those operators, and if it's not, push it onto the stack, and if it is an operator, you pop the previous two things off from the stack and then perform that operation to those two numbers. So token in this case is the operator. Pop the previous two things off the stack, perform that operation on those two numbers, and then push them back onto the stack. And I'm converting them to floats. Could have used ints, but we'll just stick with floats. And then, when this is all done, the very last thing I will have pushed onto the stack is the final result. So I'm going to pop that off and return that. Okay, so print eval postfix 2, 3 plus. That should give us a 5. This should give us, let's see, 3 plus 5 is 8, then times 2 is 16, and this is the expression that we just saw in that Word document that I had up. So let's go ahead and run parser, and sure enough, we get 5, 16, and that 39, as mentioned in the word processing document. pretty cool stuff. So this is actually how computers parse expressions and break them up into something it can recognize. Actually, when your computer is going through and parsing your code, it's also operating on a stack to make sure that you have valid syntax. So if you have code that has parentheses in it, for example like this, a left parentheses like this would be pushed onto the stack, and then you might do some things with these things, and then when you encounter the right parentheses, you pop that left parentheses off the stack. I mean, there's a lot more going on in that, but it gives you an idea that when you are going through a piece of code and trying to write a translator to check to see if somebody has written valid Python code, you actually are going to use a stack to do at least part of that processing. Alright, we are going to see some more examples of stacks. In fact, the next thing I want to do, and this is a bigger project, is to take an infix expression like this, convert it to postfix, and then that will give me a way to evaluate an expression written in infix as I compete with the chirping birds outside for loudness.